video today is going to be about doing the end work on this part, just milling a little counterbore and some chamfers, and a little bit about steady rests and what you can do with them. I show a little explanation of that. So we're going to get over to the machine over here. We're going to indicate this part in and get set up to do the counterbore on the end of this part. So that's what this video is going to be about. See, this is the part we're working on in the lathe, and we have to prepare the end of this part to accept the tailstock center and the piece that supports it on the center. I'll show you a picture of that later in the video. So we have to do the end work on this part, just the counterbore. These other holes, the 3 holes, the center hole of course is already in there, but the 3 other holes get done later in a later operation. So let me bring the drawing up here on the screen. So what we're going to do is this 1.502 +1 minus nothing counterbore, and down here you can see it's 130 thousandths deep, +1 minus nothing. We're going to do this 15 thousandths by 45 chamfer, and up here you see the 52 thousandths by 30 thousandths chamfer. That's all we're going to do on this setup, just to get it ready so we can hold it with the tailstock center. Here's the picture in the CAM software of the model and the program. I'm just going to run the simulation so we can see what's going to happen when we do the actual machine work. We're going to come in here with a 1/2 inch end mill and face the rough face off the rough stock off the face. Then I'd come in with a 3/8 end mill with a tip radius on it to rough out the counterbore. So it's plunging down at the helix right now. If we look over here, we can see the depth in the z-axis it's coming to. It's going to leave 5,000 stock on all surfaces for the finish end mill. Spiraling out in this kind of a cut, it's just rotating the c-axis and moving the y-axis. I mean the x-axis. The y stays on 0 all the time with these kind of cuts. And the finish face and finish the bottom of the counterbore. The reason I'm finishing the face and the counterbore bottom with the same tool is because of the 1,000th of an inch tolerance. I want to maintain the depth accurately. So then it finishes the wall and the inside for the bore. We chamfer the 45 degrees and chamfer the 30 degrees on the hole in the ID. So that's what we're going to do on the machine. Okay, let's talk a little bit about using a steady rest and how it's used and what you have to take into account when using one. Let's say this is the chuck of the machine and you have your part sticking out here like this, like the setup we're doing. Then we have the steady rest jaws on the part here, like this. Now you have to be careful when you use a steady rest, because you can actually have the part, I'll exaggerate the center line of the part off at an angle like this in any direction, and it causes, the part will still run true if you put a dial indicator on the end of the part out here, but you'll be actually, when you're trying to turn or mill or whatever you're doing here on the face of the part, you'll be actually, to exaggerate this, you'll be turning a conical shape on the part because it's not running true in the steady rest. And also you're actually putting a bind on the part, and you're probably more like curving and putting a stress in the part like that. So you have to indicate the part quite carefully in the steady rest. Now in some ways you can set this up with a tailstock center. If you put the tailstock center in here, and if you have a feature on the part, you can do that, which in this case we could do that, but I'm not going to. I'm going to indicate it, but when we'll see that at the machine when we go over to the machine. But the on an engine lathe, this is the way you would probably normally set it up. You'd have a center drill or something into the end of the part, and you would put the tailstock up here, and then you would adjust each one of the 3 jaws of the steady rest to where it contacts the part. And that's a good way to do it, and it works. In this case, I'm going to indicate up the side of the part here and the top of the part and make sure I have it running true, and then we're going to indicate when we have the B-axis down horizontal, we're going to indicate the center line of the part to set up our part. The steady rest can be used actually in a lot of different ways. Say you had a part, I'll draw something like this, and you had a hole in it that you wanted to run true, but you had no way to really indicate this on the back side because it's a blind hole. And what I've done on the steady rest before is actually I bring the center up in here like this and take a little skim cut right here on the end of the part. Then I'd set my jaws right here on the end of the part, and if I had this setting in a 4-jaw chuck over here, let's call these the chuck jaws, and the chuck body, like that, I can then move my center away here and run a dial indicator up in here and put it up on the bore here somewhere, and rotate the chuck and indicate the bore to run true up in here. And I've already got the OD running true on my skim cut of the part out here on the steady rest jaws. And then you gotta kind of prepare yourself this way. On the CNC machine, this is quite easy because you can then take a skim cut out here somewhere on the OD of the part to get this running true out here, and it will give you something to flip the part around and put the steady rest jaws out here when you flip the part around and chuck it the opposite direction. And then you can put, if you can put a center drill up in the end of the part here or something, and then turn the OD. That's a way to do it. I've done this particular thing in a different way on the vertical machining center, where we took we made a fixture that set on the table like this, and we had these parts were thermal wells, and we put a pin in the fixture like this that fit the ID. I believe the ID was around 1/4 of an inch on these parts. So, and they were blind holes because we had to come back and turn a very thin wall. I think they were about 3/4 of an inch diameter titanium rods, and they had a hole gun drilled in there. I don't know, they were maybe about 12 inches long or so. They had a hole drilled up in there almost to the end of the part. So then we set the part on here with this gun drilled hole on top of the rod, and we had a way to clamp the top of the part here, but we had 2 dial indicators on here, one this way and one, if I draw the top view, actually we had an indicator like this, and we had an indicator like this. So the part's sitting on there, and we had a way to clamp this. I'm trying to remember how we clamped it. We had a way to clamp the part up here so it wouldn't jiggle around, because this is only a 1/4 inch rod it's standing on. So we of course indicated the rod up here and set our XY0 on that, and then we slide the parts here and set the Z0 on the top of the part, and I'm trying to think of how we clamped it. I think we had built up this with some aluminum blocks, and we had screws that we could adjust into the part here all the way around it, so that we could hold the part steady. I think it was actually probably a tubular shaped thing, and we had a screw at every 90 degrees like this underneath here, and we could snug those screws up, and then we come in here and center drill the end of the part, and then go to the lathe and turn it, and we knew we were concentric to the hole. You could do a similar thing on the lathe if you have your chuck here, and you chuck a rod in the chuck and get it running true, and then you slide your part over the end of the rod, and then center drill it. Just let it set on there. Typically what I do in this case is I might make this so that it gets slightly bigger than the hole right here with a taper, so that when I shove the part up there and kind of tap it on there maybe a little bit, and the friction of this interference fit of this taper right here drives the part. And then I can come in here and you turn it at a low RPM and center drill it. I've done this before too with the tailstock. And then I have a center drill running true to the hole, because if you send a bunch of parts out to be gun drilled, then the hole never runs perfectly true to the OD of the part. And so you, like I said in previous videos, you leave the OD oversized. And this is a couple of different ways to do this. I've even used this method, but when the hole was too small, let me tear this off. So I had a rod, I don't know, I think it was about 4 inches in diameter, and had like maybe a 3/8 hole going all the way up, but it was a blind hole, and there was no way I could get an indicator up in here to indicate this hole. So I actually stuck a pin in the hole that stuck out. Let me reduce the size of this a little bit. The same distance as the hole was deep here. Man, I'm kind of shaky here. And I had the part setting on the steady rest here, and I had it in a 4-jaw chuck over on this end, and I could adjust the run out down here to where when I put a dial indicator on the rod here, I could, when this was running true, and if this was running true up here already, because I skimmed the OD with the tailstock, then the hole in the part was running true. And this is another way to use a steady rest and a 4-jaw chuck to get the part running true. And then you could come and take a cut down here that's running true to your hole, and then flip the part around and get it all running true again in the actually, you don't even need to put it in the steady rest. If you're careful, you can chuck onto this skim diameter down here and get that running true in the 4-jaw chuck, and then tap it around until your skim cut runs true with a dial indicator, and then put a center drill in the end of the part. Then you're running true to your hole. So this is a number of different ways to use a steady rest. You have to be a little bit careful with steady rest, because you can actually be running out in relation to the spindle down at the end of the steady rest, if it's a long part in particular, and you could be putting a bind on the spindle and the steady rest jaws and everything, and the whole bed of the lathe if it's a big enough part, and cause distortion in the part. So this is just a little description of possible ways to define the center of holes, blind holes, and you use your steady rest. Over 1/1000th of an inch. See what we got in the way of runout down here. You really shouldn't have much of any runout on the end of a steady rest. I have a little bit there. It's got a slight bow in it right here. And almost 2/1000 run out down at this end of the part. Might be part of the problem here. So with the 0 point here, I've got about 1/1000th of an inch to run out there. Also got to take into account the diameter here because there's a difference in diameter. I turned these pretty close though, I don't think that's the case. No. Let's see what we're doing in the other axis here. This one. Make sure we're on the high spot of the radius. See where we're at here. Make sure that's 0. Okay. This is so we have to adjust this out a little bit. See if this is the right wedge. No other way. Okay. There's a bow in the part right here, in the middle, about 1/1000th of an inch. Jump over the steady rest. Look down here. Okay. It's pretty good across the side. I'll look at it across the top again just to see. Bring it to 0. Okay. And that's about 1/1000th of an inch over the length of the part. See if it'll move. It is moving. Take brute force. brute force. Never hurts to hit it harder with a hammer, right? Okay, that looks pretty good. Up and back. Gonna let that go. Let's check it one more time. It's on the side. Down here. There's a step in apart from when I turned it right there, as you can see it. 1,000. Okay. Let's go up and go out to the end of the part. The side. That looks good. I'm going to leave that alone. Okay. So let me turn things around here and we'll turn the B-axis up this direction and try that. The end of the part. Indicate the end of the part. I went ahead and moved the steady rest out further. Out further, closer to the end of the part, because there's a little bit of run out. I think there's a little bit of a bow in the middle of the part over here, and it was causing run out at the end, so I moved it out further to reduce the amount of run out there. So then we're going to re-indicate the part here, which I've already actually done. So the part runs true. Let's reset the X and the Y 0 point of the part. So now I'm going to have to touch the tools off, because I've set the Z0 here for right now to touch the tools off. I'm going to touch them off, and then we're going to run the program. Okay, that's going to do it for this video on the machining this counterboard at the end of this part. I was going through the clips and editing the video, and I noticed that maybe I didn't explain certain things I was talking about too clearly. So if there's any questions at all, please leave a comment and ask me a question if you don't understand something, or if you have any questions about any machine work in general, please ask the questions. Also, I'm kind of new with this Premiere, Adobe Premiere, and I'm trying to get these videos edited, so kind of excuse the sound. I'm still learning about sound. I know something about photography. I've done that since I've been a teenager, but sound is a whole new thing to me, and I'm learning it, and I'm trying to get it right. So the sound in this video is kind of a little flaky, so excuse that. I'm working on it. And all the comments that everybody's left on the previous videos, they've really been awesome, and so thank you for those. And people that haven't subscribed, please subscribe. And thanks for watching.